message over and over and over again without acknowledgement. It's actually because of that last bit, that there's no acknowledgement. There's really no way at the network layer of actually knowing if a node received a broadcast that should indicate to you that's probably a pretty bad idea to use for an application layer thing. Broadcasts are actually used specifically for a very important mechanism within ZigBee networks. That mechanism is route discovery. And it's actually the mechanism by which unicast transmissions are allowed to work from one edge of the network to another, or from node to node. And so what happens in route discovery is that a broadcast will go out. If I wanted to send data from R1 to R10 here, a broadcast is going to go out, and R1 is going to ask everybody in the network to send its route to R10. And that broadcast will eventually hit R10, and everybody will reply to R1 with their best path to R10. And what happens is R1, it will actually be able to construct the best next hop to be able to send to R10. Once it has that next hop, it's actually able then to send a transmission over to that subsequent node. Sorry, I jumped a slide here. I thought I had one more piece on my animation. But we'll demonstrate here how a unicast transmission will actually work. If we want to send in this diagram from R1 here in the upper left to R10 down here in the lower right. So what we're going to see is we're going to see a unicast transmission from R1 to R10 with a route that already exists, the route being established in the previous slide. What you're going to see is at the 802.15.4 layer, there's actually going to be these network layer acknowledgments between each of these nodes. So that's one layer of reliability. What's going to happen is once this data actually fully propagates from R1 all the way across the network to R10, you're going to get a second layer of reliability, which is going to be known as the application layer ACK. And so that ACK will come back, and the ACK will actually also be reliably transmitted at the 802.15.4 layer. One thing to glean from this is that means that every time we're taking a hop from node to node to node, we're actually increasing latency in the network. It may be a reliable transport, but it is certainly more expensive than a simple point-to-point network. What you also get, though, is you also get some reliability. So let's say that R7 here gets hit by lightning. How does the network actually heal itself? What happens is R1 will still attempt to broadcast to R10 along the recorded route that it has. And it will see that there will be an acknowledgement timeout when it tries to get to R7. It will then do a new broadcast for that route discovery that we talked about, and everyone will reply with their new route back to R10. So when that new route is sent, then we have this link that exists between R1 and R10. And actually, within our software, that's completely transparent to you. It will retry the transmission and do all the route discovery, and you don't have to do anything other than say that you want to send to R10, and everything will just work. There's this new specification that just hit late last year called ZigBee 2007, and I wanted to mention a few things about it. The specification defines two feature sets. There's the ZigBee feature set, which is more or less a continuation of the feature set that the ZigBee Alliance's specification has enjoyed for a few years now. And then there's also the ZigBee Pro feature set. The ZigBee Pro feature set is available from Digi using our XBZB modules and in our ConnectPort X gateways. There's a little bit of difference between ZigBee and ZigBee Pro in the 2007 specification. One thing is that ZigBee Pro actually, the ZigBee 2000 specification actually uses this stochastic 16-bit addressing. And though that term may seem a little daunting at first, what it means is actually increased reliability. There are two types of mesh networks out there. There are these cluster tree networks and full mesh networks. A cluster tree network actually uses that 16-bit address to participate in the routing activity. We have a white paper that's actually up on our website, and I can look up the full title of that, but it's from our CTO, Joel Young, and it describes the difference between those two types of networking technologies. Stochastic 16-bit addressing is essentially random addressing, and it ensures that there's not going to be a collision between any two nodes that pick their own address, and it allows for a much greater number of nodes on a ZigBee network. That was one of the changes in 2007. The other thing that 2007 provides for is this frequency agility feature. Frequency agility is the ability for an entire personal area network to change its channel should the RF environment actually change. That white paper, by the way, where we talk about the difference between cluster tree topologies and the full mesh network stochastic topology, it's called Untangling the Mesh by Joel Young under the white paper section on our website. Oh, here you can actually see a difference between the two. Cluster tree is hierarchical. Stochastic looks like a full mesh. ZigBee Pro adds some very, very important routing features. One of them is many-to-one aggregated routing, source routing, and multicast routing. I'll talk a little bit more about those in a moment. It also adds the ability to have mobile end nodes, and it adds a high security mode with a master key. The many-to-one aggregated routing feature is extremely important when you have a bunch of sensor nodes, low power nodes, that are all talking to one type of gateway device. So there's just sort of one point in the network where all the data is being brought in and out of. The reason that this is important is that in the past, in past revisions of the ZigBee specification, the routing tables would get quite full as the network got deeper and deeper and deeper. What many-to-one aggregated routing allows for is essentially each and every node to just hold on to one sort of shorthand route back to the point where it's going to aggregate the data to. This allows for much deeper and much more dense networks that are scaling into that hundreds of nodes or thousands of nodes variety. Source routing is kind of a similar concept. It allows for applications to actually store the routes along from node to node to node that a particular message wants to get passed along to. This is a bit of an advanced feature. I won't actually cover it in detail, but you can know that our ZigBee Pro offering will support both of these features. There's also multicast support. Multicast transmission support is important where you're talking to groups of nodes at the same time. This is the better way of doing a broadcast-like activity. If we take what's sort of referred to as the classic example in a ZigBee network, and you have a light switch, and it's controlling a bank of lights, if you're just doing a unicast